Okay, this video will go over chapter 4 review sheet. A lot of times most of the time I'm just going to reveal the answers. You can work towards those and bring your questions in tomorrow. But the key to this test is knowing what's in your arsenal, to solve each problem. So the first one we have is the Pythagorean theorem. Okay, everyone most likely knows that one. A squared plus B squared equals C squared. Very useful theorem to know. Okay, we also have trig, which I would spend a lot of time making sure you know how to do the trig. And we have SO, Ka, TOA, and I write it as a ratio because that's how you have to set them up. Don't forget you take the inverse of one of these, whatever it might be, the inverse of sine or the inverse of cosine or the inverse of tangent to find an angle. Okay, so if you're asking for an unknown angle, you're going to use inverse of these ratios. Okay, so we have Pythagorean theorem, we have trigonometry, we also have our 30, 60, 90, and 45, 90 rules. Okay, so if the 45, 90 rules have been confusing to you, you can always use trig to find an unknown side. Alright, so we had diagrams that worked with that. Some of you really liked those and went with it and did a real nice job with that. And then lastly, we had this drawing where we have altitude departs, and we tried to simplify this by drawing this diagram, and we set up ratios between them. It was a squared equals df, b squared equals d times e, and c squared equals e times f. Okay, so those are the 4 things. You can use those and use them well, you'll do fine. Okay, so there's the answers to the first 4. Like I said, you use Pythagorean theorem here. Use trig or your 45, 90 rules for number 2. Use trigonometry for number 3, and you use the 4th one for the similarity rules for number 4. And you should be able to get through that. There's the next 4. Notice that I have the decimal answer also, because if you use trig to figure these out, you're going to end up with a decimal answer. So 9 through 12, Pythagorean theorem, trigonometry, 30, 60, 90 rules or trig, and same thing with this. So the next 4, Pythagorean theorem, similarity ratios, trigonometry, and 30, 60, 90. Or trig. Don't forget, you can always use trig to find those. A few more. Distance formula, I have it written right there. You guys did a nice job with that, finding the difference of your x's, the difference of your y's, squaring it, then square root. Both sides. If I give you a graph, you can just count the difference between the x's and the y's, and you have an 8x3 triangle, right triangle, and you can just use the Pythagorean theorem from there. Or, find your 2 points, 2 endpoints, and plug it in. Simplifying a radical, we have your list of perfect squares. So you're trying to break the number into a perfect square times a non-perfect square, and the square root of 49 is 7, so that comes out front as 7 rad 3. And there's a whole other sheet of them, so if I'm going too fast, remember you can press pause. So there's the first 10. Remember, you can only add like radicals. add and subtract like radicals, you can multiply unlike radicals. So there's the next 10. Okay, this back sheet, if it's talking about a rectangle, draw a rectangle. If it's talking about a square, draw a square. Makes sense, doesn't it? So it's talking about a square with a perimeter, or find the perimeter of a square with a diagonal of 22. So I draw my square and I label everything that I know. I know that all four sides are equal. The diagonal is 22. And I also know that this 90-degree angle here in the corner has been cut in half. So it's a 45, 45, 90. But even if you didn't see that, you still have x and x because those are the same sides. So don't write two different variables here because it's not two different sides, it's the same side. So x squared plus x squared should equal 22 squared using the Pythagorean theorem. So once you work through that, you get 11 rad 2 as one of the sides. And from there, since I need the perimeter, I need 4 of those. So I did 4 times 11 rad 2, which is 44 rad 2. So you can leave it exactly like that, or get the decimal of 66.2. The next one is talking about a rectangle. Use the Pythagorean theorem to find this 80. And 18 times 80 to get the area of the rectangle, length times width. So my final answer here is this 1440. Number 49, it tells you that it has a rhombus with a perimeter of 60, so that's 4 equal sides. You need to know that. You have 4 equal sides in a rhombus, so 60 divided by 4 is 15 on each side. It also tells me that one of the diagonals is 24, and I know the diagonals cut each other in half. 24 divided by 2 is 12. So I end up with this triangle here that's has a leg of 12, an unknown leg, and then a hypotenuse of 15. So I took that and I redrew it. Okay, so I basically am just using the Pythagorean theorem, you see that over here, to find that x equals 9. And if one of these little sides, it's kind of small, but if one of these little parts is 9, there's 2 of them, 9 times 2 makes 18. So my final answer is 18. We learned the rules that if the two legs squared are greater than c squared, then we have an acute triangle. If they're less than c squared, then we have obtuse. And if they're equal to, we have a right triangle. So recheck those rules. And then finally, we have the perimeter of this triangle. And you can basically just do the distance formula 3 times. I kind of did a shortened version over here. To be honest with you, I counted the rise and the run of each one. So QR looks like it was 7 by 7. So that's the way I figured it out. I just went that I have a right triangle that has legs of 7 and 7, and then added those two together and took the square root of it. I have to add all these up. If I add them all up, I get the 32.1. Oops. So there's different ways you can do that. You can obviously just use the distance formula 3 times to find these lengths, but that's what you should get after you've used the distance formula.